Alright, so my name is Gabe Siciliano, and the focus of my final project was to make an after-dinner drink that produces light. And in doing so, test the effect of ethanol on the intensity and duration of the bioluminescent reaction in cultures of Pyrocystis fusiformis, seen here, which is a food-safe, non-toxic, photosynthetic marine dinoflagellate that luminesces when chemically or mechanically stressed. I did this by adding different concentrations of ethanol to samples of P. fusiformis in solution. 0%, so that was the control, so that was just distilled water, 3.3%, 6.7%, 10%, 13.3%, and 16.6%. I was motivated to do so because, to my knowledge, no one has tried to do this before. And I thought it'd be really cool. You know, there are drinks that fluoresce under UV lights that contain quinine, and there are, wintergreen candies that produce a flash when you chew them in a process called triboluminescence, but I wanted to make something that produces its own light, its own internal light. And I thought that, narrowing it down to one variable, ethanol, would be easy to test. So I measured the light produced using this circuit I designed, which consists of a photoresistor, which is photosensitive, a potentiometer, a 9-volt battery, and a multimeter, all wired together in series. It looked like this. So here's the multimeter, the potentiometer, 9-volt, and the photoresistor. And the photoresistor was set in this jar, in the lid of this jar, which I then wrapped in tin foil and electrical tape, as you can see here, to make sure it was totally light tight. I made a holder using modeling clay to hold the test tubes of solution. Each culture was 10 milliliters, and I fit an eyedropper into the lid to be able to drop solution into it. So when I drop solution in, I added the dinoflagellate culture to the jar, and I added the requisite solution and drew it up into the eyedropper, closed the jar, sealed it tight, and dropped the solution into the culture inside the jar. So a change in voltage, as measured by the multimeter here, in millivolts, indicated bioluminescence, and I recorded the change in voltage and its duration. And I got some pretty interesting results. My results showed that bioluminescence is very strongly affected by the concentration of ethanol added. So, in sample 1, there was a 0.1 millivolt voltage change. Sample 2, there wasn't too much more of a change in bioluminescence intensity, but there was a change in duration. Sample 3, 4, and so on. And my results are best illustrated by these graphs. So, as the concentration goes up, the intensity of the light produced increases in a linear relationship, as you can see here. And the duration of the light produced also increases, as you can see here. This is modeled by a polynomial relationship of the second degree. So after 24 hours, all of the cultures were dead except for the control, which tells me that P. fusiformis cannot long survive exposure to ethanol, and that the drink is best mixed in front of the imbiber in a dark room for the best effect. I say a dark room because, unfortunately, I was unable to record the taste test, as bioluminescence is best picked up by a low-light camera, which I did not have access to. It's not all that bright, but it is very, very noticeable in a dark room. When added to a glass, when the solution was added, I added 5 milliliters of solution of vodka to 10 milliliters of dinoflagellate culture, and it kind of looked like a galaxy in a glass. My buddy tried it, and he had the following to say. The moment that the dinoflagellate solution mixed with the vodka, I saw the formation of translucent spherical particles of the bioluminescent center. The luminescence had a greenish hue to it. As soon as the drink hit my tongue, I pictured myself swimming in the ocean. The drink's taste was similar to seawater. It was like briny vodka infused with the taste of the ocean. The experience was unique, and I would definitely consider drinking a cocktail drink that luminesces like that because it's a very cool sight to witness. 10 out of 10 would try again. And the reason it tasted salty was because the culture medium has the same salinity as seawater. That's what the dinoflagellates need to survive. So, overall, I consider my experiment a success. If I were to do it again, and I had more cultures and could conduct further tests, I would assess the effect of both pH and temperature on the bioluminescent reaction, because I think that those would both have similar effects. I would think that an increase in, or a drop in pH would increase the intensity and duration of the luminescent reaction, as would an increase in temperature. So I hope that you enjoyed my presentation. Thanks for watching, and I can't wait to see everyone else's.